Good morning, Algebra 2. Today we're going to do Lesson 35, Solving Quadratic Equations. This lesson you are going to use forever in all of your math classes. We need to be really good at this lesson. Let's talk about some vocabulary first. If we first start with a parabola, and we see that this parabola has been moved down 4 units. So if we sketch it, it looks like that. If I factor it and set it equal to 0, I see that when y is 0, x is 2 and negative 2. It corresponds to my function like that. We call these the zeros of the functions, the roots of the functions, the x-intercepts of the functions, or the solutions to the functions. Your book is going to use these words interchangeably. You will see those words over and over. So the question is today, where does the quadratic function cross the x-axis? And it relates to a parabola, where it crosses the x-axis. You are not asked to graph all of these, but keep in mind, because the more information you have, the more it all fits together and it confirms your results. So for this first one, I am going to set it equal to 0. Where is this function equal to 0? Notice function is y. Y and f of x are the same. When I use the word function, I'm referring to y. Where is this function equal to 0? Where is y equal to 0? Well, let's solve for x. Take the 25 to their side, divide by 4, plus and minus 5 halves when I take the square root. This parabola crosses the x-axis at positive 2.5 and negative 2.5. It's positive. It opens up. All right, let's look at the next one. Where is this function equal to 0? Always begin by factoring out the greatest common factor. Then remember, you're setting each factor equal to 0. Because if this factor equals 0, the whole thing is. If this factor equals 0, the whole thing equals 0. Now I solve for x. When x is 0, the function is 0. When x is negative 1/2, the function is 0. So those are my two solutions, my two roots, my two x-intercepts to this quadratic. Let's look at this one. This one is not given to us as y equals, but we want to set this where it equals 0. Your first step is always to set it equal to 0. So I bring everything over to that side, setting it equal to 0. Now I'm going to factor. Remember, two factors of this here and here, two factors of this here and here, such that the sum of those factors will give you the middle term. Then I'm going to set each factor equal to 0, and I see that when x is negative 5 and 3, the function will be 0. Those are my x-intercepts, my zeros, my roots. This one asked for roots of that function. If I were to graph this again, excuse me, crosses the x-axis at negative 5 and at 3, positive, so it opens up. We could do more work to find the axis of symmetry and to find the y-intercept. The y-intercept is actually negative 15 right there. Let's find the roots or the solutions to the next one. X minus 3, x minus 3. So I see a quantity squared. So if I just consider the graph right now, I see it's been moved over 3 units on the x-axis. And I see it only touches the x-axis at 3. If I set this equal to 0, sure enough, when x is 3, the function is 0. Okay? For number 5, again, we factor out the greatest common factor, and then we set each factor equal to 0. So x is 0 and x is negative 2. Alrighty? Now for this next example, we're going to work in reverse. Instead of finding the zeros, we are now finding the equation. Well, let's go back up here. We noticed that the zeros or the roots were negative 5 and 3. But we started with the two factors. So here are the roots, here are the factors, here is the equation. We've been given the equation, we have factored. From the factors, we find the roots. Well, now we want to go in reverse. We want to start with the roots and go back to the factors. From there, we want to go back to the equation. Well, notice this. This is x minus the root. This is x minus the root. That's what I'm going to do down here. I've been given two roots. I want some quadratic equation. Write a quadratic function. We know that there's a possibility of a lead coefficient. I'm going to assume that mine is 1. So I'm going to say x minus the first root and x minus the second root. This is my quadratic function. X minus the root times x minus the root. That's what you're going to do. X minus the root times x minus the root. So if I FOIL, I get x squared. 5/3 x minus 3/3 x is 2/3 x minus 5/3. There is one possibility of a quadratic function whose roots are -5/3 and 1. All right, let's look at this last one. We have gone over this problem before. We have a height function, and the height function we know, -16t squared, that is half acceleration due to gravity in feet per second squared. So we know everything's going to be in terms of feet. This is our initial velocity. This is our initial height. So looking at this example, we have an object thrown from a height of 84 feet off the ground. It's thrown downward. That negative sign means it's thrown downward at a velocity of 20 feet per second. How long, that's time, will it reach the ground? Remember, this is the height function with respect to time. So if it's on the ground, it has a height of 0. So I set my height function equal to 0, and now it's a familiar process. Now I'm finding the zeros of the function. Begin by factoring out the lead coefficient. That gives me 4t squared plus 5t minus 21. This factoring is a little tricky. We have two factors of this, so 4t and t, two factors of this, whose sum, 12 minus 7, will give us 5, will give us a middle term. Then I set each factor equal to 0. So I have a time of 7/4 seconds and a time of -3 seconds. Well, some of you think, well, -3 doesn't make sense. Well, it kind of does. It's a theoretical time. It is time before our experiment began. Because remember, we threw it from a platform of 84. My graph isn't totally accurate because we didn't throw it up, we threw it down. Okay? And so if we threw it down, then there would actually be my 7/4. This is throwing it up, so wrong. And so it hits the ground at 7/4 seconds. Theoretically, if it had carried on, or if we'd started here and thrown it up and then fallen down, that would have been at -3. But you're correct, we are not going to keep that time. It will be on the ground at 7/4 seconds. So reaching the ground, that is a height of 0. Then we factor, set our factors equal to 0 again to solve for our roots. Keep the time that makes sense. Alrighty, let me know if you have any questions. Thank you.